Okay, so at this point, you know how to take two perpendicular vectors and find the resultant. You know how to take a resultant that's on a diagonal and find the component pieces thereof. That's terrible coloring. Now what we're going to do, well, and you also know how to take a bunch of wacky non-perpendicular vectors and find the resultant. The thing that has to be really automatic to you at this point is looking at this and going, oh, okay, well, the x component of that equals resultant, cosine resultant. The y component of that equals sine resultant. That's the piece that's got to be automatic. Because what we're going to start to do now is motion in 2 dimensions. So you've used the kinematic equations, and most of you are pretty good at them. Your golden equations, delta x equals vi delta t plus 1/2 a delta t squared, my favorite. Vf squared equals vi squared plus 2a delta x, etc. Yeah, you know them. You've got a note card somewhere. You don't have to memorize them. You've got them written down. How would you apply those to 2 dimensions? Oh, we've applied them to 1 dimension. It's easy on 1 dimension. When you've got 2 dimensions, it becomes a whole lot crazier. So what we do is we break the motion down into the x components of the motion and the y components of the motion, and then we apply the kinematics equations. So now you start to have vix, vfx, viy, vfy, a sub x, a sub y. Ooh. This is why I've been saying you got to make sure that your variables are what your variables say they are. You have to be careful with that notation. This is called projectile motion. You may have heard the term projectile someplace else before. As children, some of you may have embodied the term projectile. Most children do at some point. Any object that's, I'm talking about vomiting. It was a joke. It wasn't a good one. But any object that gets launched into the air is a projectile, as long as the only thing acting on it is gravity. If we strap a rocket to it, it's no longer a projectile. Projectiles are under the influence of gravity alone. So, really, what projectile motion, the first type that we're going to talk about is this horizontal projectile motion, and it's just free fall with a push. So it's an object that has some initial velocity that is now falling. So we have 2 components to the motion. We have an x component and a y component, and what that ends up giving us is a resultant vector. It's really a parabola, but we kind of ignore the parabolic implications. So in high school level physics, we ignore things like air resistance. We regularly do the crime of ignoring fiction. We won't in Chapter 4. But we also ignore all the little sort of delicacies of this flight, and we even it out into something that looks more like a resultant for us. So what we're going to start with is these horizontally launched projectiles. And this is a nice picture. This is actually right out of your textbook. We have a red ball, and we have a yellow ball. And one falls straight down, one is flicked off a surface. Okay, I guess at some point we have to pick up all the stuff we flicked, huh? That's okay, we'll get it later. So when we look at these 2 balls, neither of them has a y velocity to start with. But one of them has an x velocity. So they have both horizontal motion and they have vertical motion. And that y-axis motion is just free fall. The acceleration is negative 9.8 meters per second squared, negative g. So the vertical motion gets analyzed using those kinematic equations. You probably want to be writing those down if you don't have your note card out. So the red ball's got no horizontal velocity. You've known how to do that since Chapter 2. The yellow ball has an initial horizontal velocity, but let me ask you this. Is there any acceleration on the x-axis if this does not have a rocket strapped to it? No. Is there acceleration on the y-axis? Yeah, but there is no acceleration on the x-axis, and that's really important. So the horizontal velocity is constant. V sub x f equals v sub x I. Or sometimes we write v f x, v I f. It doesn't matter which order you put them in. I think I tend, actually, I wrote these my first year teaching physics. I think I tend towards saying v I x and v f x. I think that makes more sense. But those are completely constant. Here's what they give you on page 100, and I would say you've seen this before, and I would say you have it on your note card. Here's what I'm going to say. This is actually derived from one of your kinematics equations. So let's do my favorite here. Delta x equals vi delta t plus 1/2 a delta t squared. Well, if we're talking about the x-axis only, this is now a sub x and vi sub x. Time doesn't have an axis, lucky us. What would zero out here? Acceleration on the x is equal to what? 0. Guess what? The entire back half of that goes away. That's all they're telling you. Is that on the x-axis, we can go back to one of our simplest kinematic equations because there's no acceleration on the x. So with that, with no further ado, let's do a practice problem, sample problem together. There we go. Okay, so we've drawn the picture. We've got how far out from the base of the bridge the rock lands. We've got the height of the bridge. That's all we're given. And we want the initial velocity. Well, we want the initial velocity of the rock. We'll talk about that in just a second. I'm going to start you off with something that took me, I want to say 6 years to figure out, and it made my life much better because my first couple years of teaching physics, when we got into projectile motion, this was one of the hardest things for me. And the thing that made it way easier and way more manageable is listing your variables on the two axes separately. So when I list my variables for these kind of problems, I do this. And I list all my x variables on one side of that, and I list all my y variables on the other side. That makes a huge difference because it will allow us a couple little visual tricks. So, on the x-axis, what variables do I have on the x-axis? I have initial velocity on the x, which is actually going to be our total initial velocity, but we don't formally know that yet. What other variables do I have on the x? Talk with your table mates. You don't have to holler out. I hear mutters of delta x. Yeah. We got delta x, and that is 45 meters in the positive direction. Move that over a little bit. There. Okay. Do I have any other? So what's my acceleration on the x-axis? 0. I sometimes put that in there when I'm starting off with these, just as a reminder to myself. You don't have to write that, but that's one that I find is useful for me as a reminder, like, no, there is no acceleration on the x-axis. You'll get to a point where you won't do that anymore, but starting off you might want to. Okay, I don't really have anything else on the x. So let's look at my y-axis variables. What is my initial velocity on the y-axis? 0. What is my delta y? Be careful. I hear a magnitude of 321 meters, negative 321 meters. That's what I was looking for. Okay. Do I have acceleration on the y-axis? You betcha. Acceleration on the y is equal to negative g is equal to negative 9.81 meters per second squared. So of the variables that I usually have to work with, there's only one that's missing here. What is it? Well, we've addressed the fact that we want that. There's one thing that we haven't talked about yet. Time is on my side. Time forms the bridge between the two axes. It took me a long time to really understand that. Time forms the bridge between the two axes here because there is not time on the x and time on the y. Time is happening at the same rate on both axes, and therefore it is the thing that we use to connect the axes. So if we had to write an equation on the x-axis with the three variables that we've got, what would we use? Ooh, I know. Was that one that I showed you here? So I would go for, if I had to go for something, delta x equals VIX delta t. Well, what could I write on the y-axis with VI, delta y, A, and delta t? Got your note card handy, right? What if we tried delta y equals VIY delta t plus 1/2 A sub y delta t squared? Does that cover all the things that we have in that list? By gosh, it does. By golly. Now, is there anything there that we could zero out? Oh, VIY. There is no VIY, so that goes away. So we're left with delta y equals 1/2 A sub y, A sub y delta t squared. So could we solve this equation for delta t? By golly, we could. So delta x divided by VIX would equal delta t. Hey, guess what? If we plugged this into there, we would now have a single equation that bridged the two axes of the motion. Whoa! It's a thing of beauty. You're going to do a lot of these. Don't panic. You're going to get lots of practice. So let's go ahead and rewrite that. Delta y equals 1/2 A sub y times the quantity delta x over VIX squared. That's not so hideous. That's not hideous at all. Can you now solve for VIX? Of course you can, or we wouldn't be doing this. So I distributed the square. Delta y equals 1/2 A delta y times the quantity delta x squared over VIX squared. I am going to unpack this, and of course I've got my delta x squared over VIX squared not only in parentheses but with exponents, so I'm going to hold on to that for last. I'm going to multiply both sides by 2. So I get 2 delta y equals A sub y. Thank goodness for Doseri. What did I do before Doseri? I had to rewrite stuff all over the place. There we go. So I've got that. We're getting closer. Both sides by A sub y. 2 delta y over A sub y equals delta x squared over VIX squared. Now in this case, we know that VI equals VIX. It's good to make a note of that because that will not always be true, but it is in these kind of problems. So at some point, I'm going to go ahead and I'll let go of the charade, and I'll get rid of that VI sub x, but I don't want to do that without telling you about it so that you see where it comes from. Okay, so to solve for this, Lots of people are fond of cross multiply and divide. You can do it that way. I tend to just multiply both sides. I guess I do the same thing in the end. But what we end up with, okay, so I divided both sides by 2 delta y. I multiplied both sides by a sub y. I end up with vix squared equals delta x squared ay over 2 delta y. How do I solve for vix? Take the square root. Okay, so we did a bunch of fancy pants algebra. This is the point. So you've gotten to that solve, and yes, I do expect you to take every single step to get to that solve. This is the point where you go back to your variable list that you had in the beginning, and you look at the equation that you've got, and you say, well, do I have all the things in this equation that were in my variables list, and only those things? Did I throw something else in? Did I make something up? You know, if you derived something to get another variable, that's fine. But what you should find at the end of all of that is that what you have matches the variables you had to begin with. Obviously, we didn't have delta t. We used it as a bridge. We walked over its back and left it face down in the puddle. Poor delta t. We're going to do that to it a lot. So now we can plug in. Okay, so we have 3 minutes. We got plenty of time. Okay, I've got my numbers plugged in. Real quickly, am I going to end up with a radical under the, or am I going to end up with a negative number under the radical? No, because my displacement's negative. That's one of those little red flags for you, where be aware if you end up with a radical with a negative under it. Oh shoot, I got to go back and check the signs on my displacements. I got to check signs on my velocities. What's our raw answer? Okay. The kicked, flicked, and pushed problems are not terribly difficult. They're a little bit tedious. They're not as tedious as non-perpendicular vectors. Take a look at least one of those tonight. Obviously, all of those are assigned, and then you will have a page, you'll have a worksheet. So tomorrow when you come in, I want you to try at least one of these on your own. You're going to have time to work on these in class tomorrow, and then I'm going to have the worksheets ready. That's what we got. Go forth and do physics.